Hello and welcome to this video about environmentally friendly outdoor lighting. I would like to show you an overview of current studies and recommended actions for good lighting. Looking at our night sky, it is easy to see here on Earth that there is much more light than ever before. This is also confirmed by satellite images from space, which reveal an annual increase in brightness on the globe. Due to the breakthrough of LED, light has not only become cheap to operate, but also, with widespread use, the illuminants have become very affordable. This means that, according to the Light Pollution Atlas, 60% of people in a normal living environment can no longer see the Milky Way. In addition, almost 99% of the population in Europe live under light-polluted skies, and millions of insects are dying due to the light pollution. Such numbers beg the question, how can we improve it? Newest evaluations show that the street lighting accounts for only a small part of the worldwide average light pollution. To get to the bottom of it, a team conducted an experiment with streetlights in Tucson, Arizona. The US city is lit using smart city technology. So the researchers were able to change the brightness of about 14,000 street lanterns. In some places, they were operated at 100% power, while others were lowered to 30%. The researchers changed the brightness for 6 consecutive days and then looked at satellite images. The conclusion was that only a 20% share of the light emission seen was due to street lighting. The far greater proportion is accounted for by light from bright windows, illuminated signs and facades, and light around the private home or even sports fields. In a normal office, an average of 500 lux is common. Advertising spaces are illuminated at least 10 times as brightly as the general surroundings to make them more easily perceived. In the case of a car park with 10 lux, this quickly amounts to 100 lux. And in addition, they have a high degree of reflection, which increases the environmental load again. In general, of course, all areas should be optimized to fulfill their purpose, so that people can recognize things sufficiently and quickly enough, feel safe, and also experience a city. Light is synonymous with safety and creates an impact. Any modifications we make should not only consider humans. The environment can also be affected by light, whether it's an animal or a plant. Both use light, the sun, moon and stars, and also artificial light. The key point is always, what is the light spectrum and the intensity of the light? But why are animals attracted to light in the first place? It doesn't take long for various insects to be attracted to outdoor lighting. And they're not alone. Other animals also become aware of the light and use the opportunity to cover their own energy needs. But there are two different effects of light. Nocturnal animals often use the stars and moon to guide them through the night. As these are very distant and thus have little luminosity, outdoor lighting can easily bleach them out. Astronomically, a light in the universe is rated by magnitude. The brightest star, Siri, is measured with -1.46 mag, and this corresponds to a vertical illuminance of 8 microlux. A car park with just 10 lux will outshine this by over 1 million times. And in addition, there may be many other illuminated areas. Thus, luminaires are very dominant due to the significantly higher intensity for the insect eye, and an overstimulation of the sensory organs is then generated. Insects can no longer see anything and buzz around the light in a trance-like state. So how can we prevent this? The first and crucial point is light intensity. As soon as the light is no longer needed or has no essential use, it should be lowered to the lowest possible level. No light also means no insects at the luminaire. But if lighting is required, special considerations must be made. One point that is always associated with insect friendliness is the light spectrum, which should be particularly directed to the warm range. However, there are new findings from a study that was carried out in Switzerland in 2016, and different theses were tested to do with the light spectrum. The fact is, an insect sees electromagnetic waves differently to humans. In this diagram, you can see the different wave ranges. In the middle is the range visible for humans. To the right is infrared, and to the left the ultraviolet range, which we only perceive indirectly with our eyes. Our daytime vision is sensitive especially to light spectra in the green range, which appears very bright, and then shifts slightly to the bluish range at night. A moth, on the other hand, perceives a small amount of ultraviolet light, especially the UVA range, and has its maximum sensitivity in the violet-blue range. The light spectrum seen here corresponds to a 4000 Kelvin LED. This light has a blue LED chip, which splits the light into other wavelengths with a special phosphor layer to produce a whitish light. In this case, we speak of neutral white. It's obvious that the maximum proportion of this light source is in the blue range, which is also where a moth is very sensitive. For a better visual impression, we have set up a test track to see how this light colour works in an application. According to the response curves, this light colour has the disadvantage that moths feel attracted, but the essential advantage for us humans is that the light appears brighter and we can see much better. In the study, an average of 28 insects per night were counted for this light and light colour. If we minimise the blue portion of the light, fewer insects should feel attracted by the light. Thus, a thesis was born. But the result was that the number increased on average. This can be justified by the changed light conditions that in other insects, which possess, similar to us humans, a different brightness sensitivity curve. Also, a particularly warm light colour with 1715 Kelvin was tested and resulted in a slight decrease in the count of individuals at night. Therefore, reduced insect attraction can be affected by very warm light colour, but the results clearly show that this is not the major influencing factor. Another problem with very warm light colours is that for humans, essential colour wavelengths are missing and therefore cannot be perceived by us. This has an influence on our ability to recognise colours and objects. A significantly higher energy consumption can also be expected, which in turn has a negative impact on the environment. As you can see, it's not that easy to implement insect-friendly lighting. However, we have compiled the 7 golden rules for outdoor lighting from various publications and studies. The first and most important point is the light intensity, only as much as necessary and always as little as possible. This can be implemented with light management systems, which can not only have different dimming profiles at night, but can detect the presence of users and only then dim the system up or down. The second point is direct distribution luminaires. Light that shines directly upwards from the luminaire into the sky can no longer be used. In third place is appropriate lighting technology. With correctly directed and utilised light, ambient lighting can be minimised, which not only pleases flora and fauna, but is also very efficient for the operator. Fourth, light mounting heights should always be chosen in relation to the surrounding building heights. If there are buildings 10 metres high, an 8-metre pole can be used, as the buildings ideally shade the light. However, if there are no buildings at all, heights should be kept as low as possible. Point 5 is then light colour. Studies have shown that these have an influence, but a warm colour temperature of 1750 K will only minimally reduce attraction behaviour. A warm but still efficient option is recommended for insects. This can be 2700 Kelvin or 3000 Kelvin. The last 2 points describe the luminaire properties. An IP rating of at least 54 prevents animals and insects from entering the luminaire. In this way, they do not die inside the housing, but they still run the risk of burning themselves on a hot housing. Therefore, a maximum temperature should be implemented. Different publications recommend not to go over 60 degrees C, others say a maximum of 40 degrees C. A lower temperature can only help to prevent this phenomenon. By paying attention to these points, we can already do a lot for insect protection, but other areas could also be considered. Light has a similar effect on aquatic animals. Very strong directed light into water can massively reduce fish habitat. Depending on the intensity and depth of the water, it acts as a barrier to the fish, which then stop swimming. It can also happen that they swim permanently in the light cone and sacrifice themselves to potential predators. So try to limit or minimize direct light into water areas. Last but not least, plants also struggle with the wrong light at the wrong time. What happens in the natural cycle with the sun can also be reproduced by artificial light. However, this subject is more complex. Numerous studies are investigating which light makes fruit and vegetables grow faster and better. High intensities and very large blue component can increase leaf growth. If this happens in winter, frost damage to the tree can occur at sub-zero temperatures. Therefore, always ensure that the luminaire is mounted sufficient distance from the tree. This not only protects the tree, but also reduces shadows cast by branches or leaves in the evening hours. So there are many things to bear in mind when it comes to providing environmentally friendly lighting that is also good for people. It cannot simply be said that lighting must always be provided with very warm light colours. A holistic approach is crucial. Using all of the information incorporated here will help to ensure the right light in the right place at the right time. If you need any further information, please do not hesitate to contact us. And I hope I've been able to give you a good overview of this topic, and thank you for your attention.